So before studying enzymes, you should be familiar with peptides, polypeptides, and proteins. So the first point to make about enzymes is that they are proteins. In fact, the enzymes are protein-based catalysts that are found in living things. So some key points here. They are found in living things. They're catalysts, so they speed up chemical reactions in living things. And the structures of them are proteins. So let's have a look at how an enzyme works. So here I've got an enzyme. So there's my enzyme. And here, this little area here is what we'll call the active site. Okay, so the active site is a little cleft or crevice which is a part of the shape of an enzyme. And this is where the reaction takes place. The reactant molecules, we sometimes call those the substrate. So in this case, the substrate might look something like this. So you can see here the substrate fits precisely into the active site. It's just held at the correct orientation. And only molecules whose shape fits the active site will actually react. And sometimes we call this the lock and key hypothesis, whereas that's the key and that's the lock. So the substrate shouldn't only fit in the active site, it must sort of bond to it temporarily, because remember this is a catalyst, so this enzyme can be used again. Now, this active site of the enzyme can be very, very selective of the shape, so that many enzymes are only going to catalyze one or two reactions. And we sometimes say that the enzyme is what we call stereospecific. Now, what we mean by stereospecific is that the particular enzyme can only bond to one enantiomer of the substrate or drug. So if we took a mirror image of this molecule here, it wouldn't bond to the enzyme. And that's what stereospecific is. Now, what we can do is we can synthesize a drug. And so what the drug can do, so we can make a drug, which is essentially just a molecule. And we make the drug so it looks a little bit like the substrate. So it might have this sort of structure in it, this shape, but it might have some other bits coming off here perhaps. And because it's this shape, it will fit into the active site. And what it will do is, it will block the active site. And we call this drug an inhibitor. We call it an inhibitor because it inhibits the substrate from bonding with the active site, because the drug is the same shape. Now, computers can be used to design drugs like this. So increasingly chemists are beginning to understand the factors that influence the shapes of these molecules. So they're now able to use sophisticated computer modeling techniques to synthesize or predict the shape of potential drugs which would fit directly into these active sites.